which looks like this. This is a 16-bit opcode. So what does this opcode indicate? So these two indicate the register number. It's a 4-bit number, destination register and the source register. So these two will be added, and this is the opcode for the add ADC, that variants of instructions. So this RD, so this will be some number. So equivalent, suppose I shall tell you, let me just figure out, R1, R2. So destination, suppose this is add R1, R2. So suppose I tell you that this is add R1, R2. So this one will be RD, so this one will be for 1 it will become 0, 0, 0, 1. For 2 it will become 0, 0, 1, 0. And this will become, this is 4-bit, 4-bit, 4-bit. So this will become 1, 1. Then the R 0, 0, 0, 1, 0, 0, 1, 0. So this is 4 plus 4, 8 plus 2, 12. So then this will become, okay, give me a second. So just give me a second. So this tells you that this is add instruction. So this is 8. This will be 4-bit RT. So what will be R? What will be T? Okay, I'll just tell you this. So for example, so when it is, let's say the other instruction is let's say ADC, add with carry. Suppose I have a instruction like this, ADC, RD, RR. So what does it do? It shall do RD will be replaced by RD plus RR plus 1. And similarly, the program counter will be incremented by PC will be PC plus 1. So that leads to what is known as microstepping. So let's discuss what is microstep. Okay, sorry about that. So microstepping. So what are the micro steps? Suppose I have this instruction, simple, add with carry. Is R1 and R2. So what does it do? It basically has to be replacing R1 with R1 plus R2 plus carry. So step number 1. So this is an opcode which is a 16-bit code which is stored in this memory 001. This is the opcode, equivalent opcode. 11, then RD. RD means the source and destination. So then there'll be 2 binary numbers here. I'll tell you later. So then the destination register and the source register. So destination is, let's say, R1 RD. So this is your source register. This is the destination result should be there. So there'll be 0001, then 0010. So this 16-bit opcode is actually stored in the memory location, which is pointed by the program counter. So program counter points to a memory location where this 16-bit opcode is stored. So step 1 is in this clock cycle. This is one clock cycle, let's say. This is one clock cycle. So in the rising edge, you will see timing diagrams. This address will be, so inside the architecture of the Atmega 32. So if you see the architecture, there is a address bus and there is a, if you look at the architecture, let me just copy paste the architecture for you. So this is the architecture. So in this what happens? This program counter will go to the flash memory. So when there is a memory, the memory has a structure like this. So this is your flash memory. We will talk about memory. So this has to accept an address. Then it will give back these instructions which are stored here. So this is a read memory, read-only memory you can say, but it can be programmed. You can also write it by special things. So this is your address. and this is your data, which is 16-bit data. So this data, so when the program counter loads address here, this data is the instruction code or opcode which comes to the instruction register. So maybe in this clock cycle, so here the address is loaded, then in the falling edge or maybe in the rising edge, after some time the data comes, the code comes. So this is address, this is your opcode. Then in this falling edge, there will be instruction decoding, then timing, then addition takes place here in this level, add. So all these operations are timed inside this clock cycle. So step 1 is loading the address, step 2 is getting the instruction out, then step 3 is decoding the instruction, then 4th is to execute the task. So these are the small micro steps. And if you just if you plot the micro steps with respect to the clock cycle, this is known as timing diagram. Is that clear to you? Or any questions here? Shivan Praveen, are you there? Shivan Praveen. Shivam Praveen. Shivam Praveen, are you there or not? So Shivam Praveen should be removed. Puja, and put a note there actually. Shivam Praveen. All right. So this is a first instance. Okay. Then Hemant, Mumudi Hemant.
Yes, sir.
Can you tell me what exactly I taught you just now?
Yes, sir. The program counter will give the address to the flash memory.
So what do you understand by opcode?
Opcode. It is like the binary 4-bit, like it's the binary representation of the mnemonic, like the instruction.
So how many bits are there?
16 bits for add and ADC.
Yes, 16. This is all 16-bit. Instruction size is 16-bit. Okay.
Yes.
So how many cycles this instruction takes for execution?
2 cycles.
No, it takes one cycle.
One cycle.
It takes one cycle. So what are the different micro steps in that one cycle? Or I will ask somebody else. Sai Narayan, are you there?
Yes, sir.
Please tell me what are the different micro steps in executing a program code or something.
Sir, for this one, we have to get the address and then load the opcode.
Where from the address will go?
Address will
basically the operation is where?
From flash program memory, it will come to the instruction register. The flash program memory stores the code.
So where is the address of this flash memory? Flash memory means it has any memory has an address and the data. Okay. So yes. In the flash memory, where is the address stored?
Sir, address of the registers we are giving right in the opcode.
Where? No.
Like
the address of the location where the flash is stored.
Okay, sir.
Where is it?
Sir, in the program memory where RD and RR.
That is program memory, but who is having the address of that location of the program memory?
General purpose registers will have that address.
That is the not listening. The program counter has the address.
Okay.
Program counter has an address. Okay. So can you guys find out what is the size of the program counter for this Atmega 328 size? Anybody who can tell me by from the manuals or whatever, what is the size? Nayanjoti Badjana?
Yes, sir.
The size of the program counter bit numbers. How many locations it can address? What is the maximum size of your flash memory?
Sir.
Go to the manual and find out.
Yes, sir.
For this particular controller, what are you using? Maximum size of the flash memory. How it will be decided? So the number of bits in the program counter decides the number of address locations. Okay, so how many bits the program counter has?
How many bits program?
You read from the manual, you tell me.
So flash memory is 32 kilobytes.
No, 32 kilobytes, but it is organized like this.
16K into 16.
Each, then there will be 16K into
16.
So that if you want to address 16 kilobytes of memory, what should be the size of the program counter?
16.
14 bits.
16 bits.
14 bits. Okay, see, so this program counter is this flash memory is organized like this. It starts with the memory location 0x. 0x means what? Why I am writing 0x? Hey, Bharat Krishna, why I am writing 0x? Bharat Krishna, 0x means hexadecimal. This is the way we write. This x means 0x means it's hexadecimal number. So this is organized like this from all zeros. So that means this is equivalent to 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And here it is 0, 0, 1, 1. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So this is total is 16 kilo into each location is about it's 16 bits. So when the program counter has some number within this, so it will point to a particular location here. So whenever the clock is going like this, when you start resetting, so what will happen when you reset program counter is at all 0, 0, 0, 0. It will start from here. So it will load the address because this address has to go to the flash memory. Flash memory has one address bus. This address comes from the program counter. Then the opcode comes to the instruction decoder. Opcode is 16 bit. So all these AVR instructions are minimum 16 bits and the maximum it is 32 bits. All right. So this information you please keep it in mind because you are going to write a code after this. So let's look at some of the more complicated instructions. We are not in the class, otherwise it will be difficult to. So for example, let's look at an instruction. It is called bit clear, BCLR. It is called bit clear. Okay. So generally, how does it look like? The operation code looks like this: BCLR, a number S. This number is within 0 to 7. So it can be 1, 2, 3, 4, 5, 6, 7, whatever. So equivalent opcode for this is this. This is also a 16-bit opcode. So it is 1001. It tells this kind of instruction. Then 0100. Then the bit number. Bit number is 3-bit, is it not? So for example, suppose you write bit clear 5. 5 means 0, 1, 1, 0, 1, right? So here it will be 1, 0, 1. Then there will be 1, 0, 0. So this represents this is the qualifier or the identifier for this instruction. This is the identifier. Baki it is fixed 1, 1, 0, 0. That's all. So this is the equivalent opcode. So it clears the bits in the status register. So it clears the bit in the status register. A status register is an 8-bit register. So if you look at the status register, it looks like this. So it clears a particular bit number in the status register. Alright, I am just sharing this whole manual to you guys. Then I will ask questions. You have to explain one instruction, which I will tell. All of you be alert, okay? I'm sharing the manual right away. So please see, I have uploaded this AVR assembly language manual, which is a more detailed manual. All of you please open this. Pooja, are you please alert because I'm going to ask several questions. Alright, please open this. All of you please open. Could you open this? Arundhati.
Sir.
You please open this. Jasa Krishnan, could you open this?
Yes, sir.
Come to around page number 36, 35, in that range it is there. So there you will have a detailed description of each of the instructions. Naushin, I am asking question to Naushin. Are you there? Come in video. Naushin. Hello,
Yes, sir.
Naushin.
Yes,
Yeah.
sir. Yes.
Please come in video. Now you tell me this instruction.
Yes, sir. Which one?
Yeah, I am telling you. Just go 1 minute.
Yes, sir. 1 minute.
CLI.
Like 1 minute. I'm downloading it.
CLI page number 69. You explain this instruction.
I'm still downloading the file.
Okay, so then let me just go to some other person. Mukul Kumar. Mukul Kumar. हेलो मुकुल कुमार, पूजा उसको रेड फ्लैग लगाओ और उसको ये करो, रिमूव फ्रॉम द मीटिंग. मुकुल कुमार को प्लीज रिमूव फ्रॉम द मीटिंग. ओके, जंगम दिनेश.
Yes, sir.
Jangam Dinesh, have you downloaded?
Yes, sir.
Okay, so now you tell me about CLH, page number 68. Okay, CLH, this is instruction.
Clear half carry flag.
Yes. First of all, you explain what is half carry flag. So which bit of the status register is half carry flag?
Sir?
Which bit of the status register is the half carry flag? Status register most significant bit is 7, suppose. So which bit is half carry flag? Status register means SREG.
Yes.
Where is that? Which bit? If you count the bit number 0 to 7 from right to left. So which bit the half carry flag? Half carry is H. Which one?
Fifth bit.
Yes, 7, 6, 5th. So that carry is generated from the 4th bit. You know, if you half carry flag, if you see half carry flag, you see, you explain half carry flag. Okay, now you tell me what how many cycles of instructions? How many cycles it will take to execute?
1 cycle.
What is the opcode? Tell me in hexadecimal, what is the opcode? Opcoding, please tell.
1001 0100
No,
1101.
tell me the hexadecimal number. Hexadecimal. You know hexadecimal numbers? You count 0, 1, 2, 3, 4 like that up to 9. Then A, B, C, D, E, F. So this is a best 16 hexadecimal number. So what is the equivalent hexadecimal for? 1001 is what? 9. Then 0100 is 2. Then 1101 is what? A, B, C, D, E, F. Which one? E.
14.
Then 1000 is 8. So this is your hexadecimal equivalent. You can write this as 0x92D8. Okay. So this is the instruction code.
Okay.
All right.
Sir, 0100 will be 4, right?
This is 16-bit. 01.
Sir is saying the code would be 94D.
010 is 4. Yes, right. This is 4. Yeah. Thank you. Thank you for 094D8. Okay, now Nausheen again.
Yes, sir.
You have downloaded?
Yes, sir.
Now let's see the instruction. JMP, jump. Go to J.
Yes.
Explain the word jump instruction, JMP. So how many bytes of instruction it is?
32. I mean,
32 bits. Right.
4.
4 bytes. Correct. So tell me the K. What is the value of K?
So like the K should be a value of like it should be an address.
It will be address. So what will be the address? Where is the address? What is the maximum and what is the minimum value? If it is a 14-bit program counter, you tell me with respect to program 14 bits. So we are discussing this instruction, JMP. Okay, page number is what? Page number is 103. 103, right?
Yes.
So the instruction format is JMPK. So what is the value of K, maximum and minimum value? If the program counter is 14 bits, so how much memory it can address? 4 into 4 kilowatts, right? 16 kilowatts, right?
Yes,
so if you look at that, so this is M, so 4M kilowatts. So M is 4, right?
Sir?
M is equal to 4. If you look at this, jump to an address within the entire 4M watts. 4M is 16 kilowatts. If it is total, all 16 kilobytes of memory is there.
Yes, sir.
If it is not there, then 4 kilobytes of flash is there, then K will be just 1, right? Depends how many. Maximum you can have 16 kilowatts. 16K into 2, that is 32 bytes total.
Yes,
16 kilowatts. So what is the M if you have got all 16 kilowatts? So value of M is equal to what? So 16, sorry, the K is 4K. So that means this is 4K. So 16K watts, right? So that means it is 4 into 4K. So M is equal to 4K, right?
Yes, sir.
So what will be the value of K? K is in between. Look at that. K value maximum, minimum can be 0, maximum can be 4M. That means 4 kilobytes, 4K, right?
Yes.
Is it clear?
Yes.
Now we explain the opcode. Fast line opcoding, find out.
So first is like 1001,
Yes.
and the next one is 010K.
K will be what? K will be
Uh,
the binary number, okay?
Yes, sir.
And that will extend to the next also, I think.
So there are like 6K bits here
Yes.
in
So
the
the
total.
K value will be replaced, that's all. So
Okay.
what happens to the program counter?
It changes to the value of K.
Which flags are affected?
No flags, I guess. No
So how
flags.
many cycles it takes for execution?
I think 1 cycle.
No, you are not looking at the manual, that's the problem. It is written clearly there, 3 cycles.
Okay.
Can you
Yes,
see that
yes.
or are you not seeing it?
Yes, so now I saw it. Yes, please.
Yeah, are you sleeping? I don't know. Actually. Why are you talking like this? Completely drowsy.
That's sick.
Be careful in the class, okay? You should be attentive, otherwise I cannot help you. So 3 cycles, okay? So generally what happens now, you guys come back for recommendation. So I write the reco because my reco works very well. You don't know perhaps. So then you are on my insincere, I will not be able to give you a good reco. Remember this. That will also be a very long term, you will lose relationship with me. Be attentive in the class. You are attending the class, be attentive. Otherwise, don't attend the class. You are absent, fine, I will not mind much. But being in the class, if you are not attentive, then. Alright, so tell me why it takes 3 cycles? What is the logic? There must be some logic why it takes 3 cycles. What is the mechanism? In the first clock cycle, what happens? In the second clock cycle, what happens? Just give a guess. You may not be knowing, but you can guess.
I think like for 4 there are like K values in 3 4-bit things. So probably first
So K is a number which is stored in, so this is first of all, you have to get the opcode. So this is a 2-word opcode. So at least you need 2 memory access, flash memory access, because first opcode will go PC, then next PC plus 1, they will go to the next value. So you will have 2 consecutive flash memory read, code read. Is it not, Nausin?
Yes.
When you get the first opcode, that is 1001, 001, suppose K is equal to 5. If K is equal to 5, so you replace 5 with that number. So you get the first 16-bit number. From the first 16-bit number, you know that the next 16-bit number has to come. So there are 2 consecutive opcode fetch. It is called fetching the opcode or getting the opcode. That's called opcode fetch. Then the name we call as opcode fetch. So we call it as opcode fetch again. So then what?
So then 1 cycle to update the program counter.
Then 1 cycle to
Update the program counter.
for 1 cycle. Then there will be decoding. So decoding in the first cycle, second cycle got done. 1 cycle to change the program counter, because program counter gets automatically incremented by 1. But if you have to override the program counter by a completely new address, so it may take some time. That's why it is 3 clock cycles. All right.
Yes.
For Atmega 328, the one which you are using. Okay, Nausin, thank you very much. So let me also ask somebody else. There are some extended instructions, don't worry about that. Those things you can do later on. So let's okay, so let me pick up somebody like Harsh Singh. Can you come in, Harsh Singh?
Yes, sir.
Okay. So thank you. So can you go to iCall? iCall. This is iCall. First you explain the instruction. That is in page number 98. Page number. Go to 98 page. You explain it very nicely as if you are teaching. Come in video, then just tell about iCall. What do you mean by this iCall instruction?
So it calls to a subroutine.
How?
So like first it in the program counter.
How many iCall? Just iCall, or there is any operand with that? Just iCall you write, or the iCall something?
No sir, no operands.
Okay. So which subroutine? How it calls the subroutine? That means the program counter has to be replaced by some address.
Yes sir, in the Z registers.
Z register. What is Z register? You know,
So
registers R0, R1, R2 up to R31. Which one is Z register?
R30 and R31.
Very good. So these two registers, this comes to program counter, right?
Yes sir.
So the program counter size is 14-bit, then they will be ignoring something, right?
Yes sir.
So you can see which one they will ignore, which one they will ignore. You can find out. Okay, so it depends upon what is the size of the program. In this case, suppose it is 14-bit, so this will come within that. So tell me the what happens to which register? If you execute this, program counter is replaced with the Z register contents. Right or wrong?
Yes, and the return address is stored onto the stack.
Stack. So, so stack means what is stack? What do you mean by stack?
So I think in the stack memory.
What is stored in the stack? It is pushed to the top of the task. So what exactly is stored in the task stack?
So the return address to
return address is which address? Next address. That
yes,
means
sir.
PC plus 1. PC plus 1 will come to the stack register. Then which other register will be affected? Stack pointer has to be decremented by 2 bytes or not?
Yes,
because
sir.
this will point to the okay. So then program counter will be replaced by what?
The contents of the Z registers initially.
So what is the opcode of this? It is a fixed opcode because there is no operand. If there is a operand, then opcode will bear the operand. So now it is a fixed operand. So what is the opcode in hexadecimal?
So 0x9509.
Thank you. So tell me how many cycles it takes?
In a 16-bit, it takes 3 cycles.
Why you think it is 3 cycles?
So like one to fetch the contents of the Z register, then to increment.
No, Z register is already there inside the processor. So no extra clock cycle should be required for that. Remember this. Whenever there is a memory access, then there is a chance of no extra clock cycle. If there is no memory access, the chances of extra cycles are less. So how many memory accesses are there here?
Memory access is like only one from the Z register.
No, memory access, flash memory. How many times you have to go to the flash memory or data memory? How many times you have to do memory? See, processor has a ALU, etc., and there is a memory which is also on board, but is external. Like there is a data memory or SRAM, and there is a program memory. So how many memory access are there in this instruction? Fast memory access is it has to read the instruction code that is called. So that is called opcode fetch, getting the opcode, which is a 60-bit opcode. Okay.
Yes. Sir.
Then what is the other memory access?
So changing the stack content.
Yes. So there is a stack also which is in the memory. You have to push into the stack. 2 memory access. Then program counter is loaded with Z. So there are 3. So therefore it is 3 clock cycles. There are some registers very high profile processor, it is 2 clock cycles, but generally for 8 Atmega 328 is 3 clock cycles. Is it clear?
Yes, sir.
Okay, so let's go ahead. Thank you very much. So go to page number 112, Hemosri.
Yes, sir.
There is a restriction called LD. So what does it do? This is called load indirect from data space to register.
It loads byte with or without displacement from data space to a register. So that is a description.
What is the format? How many operands are there? For example, if you look at the first LD R30Z plus, you look at the subsystem, what happens?
Sir?
You look at the syntax. LD R30Z plus means what? What does it do?
I think it will load memory data from Z to R30 register.
No, Z is what? Z is a 2-byte. It's a 16-bit register, right?
Yes, sir.
So, but which data? 16-bit. So Z has some 16-bit number. So data will come from where?
Stack memory.
No, that 16-bit number is the address. Okay.
Okay.
So from this address, data will be read to whatever data is there. It will come to RD. Right?
Yes.
Then it will be incremented or decremented depending upon what is Z plus or Z minus.
Z minus.
Okay. So it is used for lookup tables, matrices, etc. Okay. How many cycles of the opcode is of course given here? You can see. Okay. So it's a 16-bit opcode, depending upon which one variant you are using. There are a lot of variants, as you can see. So no status register is affected, but it takes how many clock cycles?
It takes 1 clock cycle in case of 2 bytes.
Yes. If it is 1 word, it takes 1 clock cycle. If it is 2 word or something, there is a number Q here now. So this is the number you can say. In some cases, it will take 3 clock cycles also. All right. So this is the. All right. So now, so let us all write a code. Okay. So Pooja, please create. Add two 128-bit numbers. This is the code number 1. Please do that. Add 2 numbers A and B and keep in C. So A is 128-bit number. That means this is maybe something like hexadecimal A, B, C, 1, D, like that. It's a 128-bit number. And B is another 128-bit number. So both are stored in some memory, data memory, or SRAM you can say, starting from some location. Then C will be stored. So this will be in how many bytes? 128 bits means 16 into 8, 16 byte number. Two 16-byte number you are adding this here. So in the SRAM, they are stored in consecutive locations, 16 consecutive locations, another 16. Then the result will be the next 16 or whatever consecutive locations, because there will be 17 bytes or so. Because 16 bits, 16 bit you add, maximum there will be 129 bits. So it will come in 5 bytes, 17 bytes. So it will store. Please do this. Please do this and upload. All of you do. I will be seeing your screen. Arvind. हेलो अरविंद.
यस सर.
तुमने उनको बताया क्या असेंबली लैंग्वेज कोडिंग?
हेलो.
तुमने असेंबली लैंग्वेज कोडिंग कैसे होता है वो यार इसमें दिखाया
सर नहीं सर.
तो एक बार पूजा दिखा गया क्या?
नो सर. नो सर.
अच्छा अरविंद, तुम एक बार उनको दिखा देना. अभी हम लोग चुपते तो कोड लिखने दो. अभी थोड़ा देर में तुम 2-4 इंस्ट्रक्शन दिखा दो. take your time, 15 minutes. Okay. थोड़ा दिखा दो. Chart subtract इस तरह का.
Sir, where do we write the code?
You write just in the notebook, just like simple. I'll share one code, how the code is written. That will make things clear to you. I'll show you one code, don't worry. First of all, you store in the memory location, it is already there. It is something is already there. I'll share some codes with you right now. Give me a second. Write like that. Suppose I give you a code like this. All of you please see. All of you please see. Before writing the code, you see this. Let me write like this. LDI, all of you please look at this code. R20 dollar means this is decimal number. The 0x is hexadecimal number. If you put a dollar symbol, it is a decimal number. You can see. Then LDI R21 13. Then odd R20 R21. Now, what will be the result of the following codes? Tell me. Any of you plus calculate and tell me. गुरुवंश सिंह बताओ भटिया. रिजल्ट क्या होगा? गुरुवंश सिंह भटिया. गुरुवंश सिंह भटिया नहीं है, उसको ये करो. पूजा हरिद्र.
Yes sir, I will.
निकालो और उसको एक रेड लगाओ उसको. ठीक है.
Sir?
हाँ, yes. Who is speaking, please?
Sir, Tana, a result of 28 would be stored in R20, right?
Yes, correct. Can you tell me how many cycles of instruction?
Yes, sir. Just a minute.
Find out. Mata Himabindu. Matta Himabindu.
Yes sir.
Okay. Can you tell me how many memory locations this will take? How many bytes of memory? This code will occupy how many locations?
2 bytes of memory and it will complete in 1 cycle.
No, that is true. But how many? These three things, three instructions. How many bytes of memory it will take?
Hello, sir.
I'm asking him, Bindu. Don't worry. Anybody? What is your question?
Sir, I am Guruvansh.
No, Guruvansh, you are not responding. You have so you are out. Please leave this class. This is the first mistake you do. If you don't respond in another 2-3 times, you'll be. I will not take you very seriously. Okay. Okay, Himamandu, please shut your mouth. Himamandu, please go ahead.
Yes sir.
Yes.
First will be we are loading R20 with.
How many bits of code is this? Of code. How many bits? This will be 16-bit, 32-bit. How many bits?
16 bits code.
Have you seen? Go to LDI, that instruction. Which page number? I'll tell you right now. LDI is which page? $115.
Okay.
See how many of code is 16-bit. Okay. Yes, it is 16-bit, correct. So it will take 1 clock cycle?
Yes, sir, 1 clock cycle.
Good. So this is 16-bit, this is 16-bit, then this is also 16-bit. So total 6 bytes, right?
Yes, sir.
And
Two
3
keys.
clock cycles, right?
Add will take only 1 clock cycle.
But these two also take 1 clock each, right? So 3 clock cycles. Total this is the whole code. This code is having three things, right?
Yes, sir. Yes, sir. For whole code it
3
is
clock
3.
cycles. All right. So now you guys write the code which I told, right? Adding two, say, 128 numbers, 8-bit numbers. खिड़की खोलेगा खुलेगा सर खिड़की Then you write this code. Put the result. R20, R21. This is low bytes. This is the high bytes. This is the second problem. So first one and this is the second one. I'll give you 5 to 10 minutes. Please complete it.
Sir.
Also write the number of memory locations your code will take, and also write the number of cycles, how many cycles it will take execution. These two codes you write nicely and upload in the assignment section. Pooja, create the assignment. Sorry, Anshul Mina, are you there? Anshul Mina. Anshul Kumar Mina is not there. So, Pooja, please mark it. Anshul Kumar Mina is not there. Pooja, please take the note.
Sir. Sorry, sir, I had a question.
Okay, please. Okay, Amritaksha. Okay, please.
Yeah. Sir, for storing the 128-bit data, we need 16 registers. So, what
No,
command?
memory locations. So memory
Yeah.
locations. You put in the memory locations. So then you have to add one by one.
Yeah, so, like, what command do we need to use to store it in 16 different registers?
No. It is already there in the memory. The memory is in the data RAM, SRAM, which starts with a number. So you can take a number like, say, a 16-bit number. Any number will take. So from that number onwards, you can bring that number in the Z register. Then should I give you more instructions from the Z register? Then you can use that Z register to read the number, right? So you can use this load command, load from memory. Let me tell you which page. Just give me a second. You can go to page number 116. You'll get some idea. Go to page number 116. It is saying load directly from data space. So K is the address. So that address you can see it is a 16-bit address. Are you getting my point? Page number 116 of the AVR instruction set manual, which I have said. Yeah. Are you getting it? Purkaita?
Yes, sir, I'm looking at it.
Hello, sir.
Yes, who is speaking? Please raise your hand. Okay, Devendra, tell me.
So, sir, we will get first location, let's say, means K. So, for second bit, we need to do K plus 8 or K plus 1?
K plus 1, K plus 1, K plus 2, K plus 3. So there are 4 locations. That will be the first word, then second word. So it is the LSB, so you can assume that it is stored in the order, first least significant byte, then MSB. So first you add LSB, then add LSB, the next byte with carry, next byte with carry.
Yeah, so to take next byte, we need to take K plus 8 or K plus 1?
K plus 1, K plus 1.
By this, we will get next beat, na, sir? For next.
No, byte, next memory location. If you go to the page number, you go to page number 116. Look at this K. K is a number, right? This number K you can store in the Z register. So instead of LDS, use load. You can use load indirect. That means using Z register. Okay. Using Z register as the address.
Okay.
That there is another instruction. Let me just go to the table. I'll give 1 minute second. The data space is the memory where from you can load. Okay. But if you use a constant K address, then increment is not very difficult. So you put that constant in the register, some register, and from which you load. I'll tell you just the instruction, which instruction it is. You go to page number 25. Page number 25, okay. Table 4.4. The one manual which just I shared, that one. So there is this LD, RDX plus and Y. So you can use X and Y location.
Yes, sir.
Similarly, Z location you can use. X, Y, Z. See. अरविंद तुम क्या एक डेमो अभी दे सकते हो 10 मिनट में असेंबली कोडिंग का ना कल दोगे?
सॉरी सर, अभी नहीं हो पाएगा सर।
ठीक है, कल जो है ना क्लास, उसमें थोड़ा दे दो।
ओके सर, ओके।
छोटा मोटा कोड को कैसे वो असेंबली करके, कहीं अभी उनको असाइनमेंट मिलेगा ना अभी इस वीक में असेंबली कोडिंग का।
ठीक है सर,
ठीक है, डिले फिले कैसे जनरेट करता है, क्या करता है, ये सब पता।
Sir,
नौशीन बोलिए।
sir, like in the page 25, LD, RDX and RDY, like X and Y, they can be different addresses, right?
Yes, X is a register pair. You keep one address there. Y is another register, keep another address there. Z is another register pair, keep another address there.
Okay, sir. Sir, and the increment, by how many bits does it get incremented?
If you increment, it's just see location X. If you increment it, it goes to the next location. 1 byte.
Okay.
It's a byte memory. Now you check it. If you go to the LD, go to page number. You see LDX. If you go to page number, LD will be there. Page number. You go to that description of that. Let me do that. Page number 112. Go to page number 112. We discussed just now. LD register, we have just 112. Page number 1. It is described there.
Sir,
Yes, please.
so we have 32-bit processor, right? So
No, not 32-bit. Who told? It is 8-bit processor only.
Okay. We are
3
not
to
doing it for
3 to 8, 3
Atmega
to 8
32.
means that is giving you the flash memory size.
Okay.
32 8-bit locations. 32 kilobytes of 8-bit location. That is the flash memory size.
Okay, sir.
Which is 16 kilowatts. Okay.
Okay, I got it.
It is not 32-bit. Don't get this is a common mistake people do. Anubhav Saraf, are you there? Anubhav Saraf? Puja,
Yes,
Anubhav
sir.
Saraf.
Yes, sir.
You tell me, what have you done?
So I'm trying to find out how to load the memory, load the
मेमोरी में
data.
ऑलरेडी है, मेमोरी में ऑलरेडी कहीं से लोड हुआ है, तुमको याद जरूरत नहीं है, वो कैसे आके मेमोरी में ऑलरेडी है, मेमोरी को लोड करने का नहीं, मेमोरी से लेके आना है.
Yeah, that's what I'm figuring out to how, like, take the
LD instruction.
Yeah, I'm using LD, but there is 16 bits, so 16 bytes, so I'm struggling with that.
No, that so you increment 16 times. Okay, so you guys just make, instead of 128-bit, you make it 32-bit. Okay, I'll change that. Question 1, instead of 128-bit, those who cannot do 128-bit, do for 32-bit. 2 words. That means 2 32-bit numbers will be added. That's all. Okay. Please do that. Abhijit Nandan, are you there? Abhijit Nandan?
Yes, sir.
What is your difficulty? Tell me. Suppose can you do 32-bit number addition using LD?
Sir, I have joined just now, sir.
Why?
I was late today, sir.
No, late today means you will join without my permission. After 1 hour. Please take a note, Puja. This Abhijit Nandan is highly insincere person. Okay. He was never there actually. Just to score red bar. You can't join in between the class after 1 hour. 5 minutes late is fine, but 1 hour late you will join. क्या problem है यार? अजय राम मीना, are you there? See, तुम लोग का जिसका रेड मार्क होता है ना,
Yes, sir.
दो तीन बार रोड मार्क होने के बाद मेरे पास वो आएगा इन्फॉर्मेशन। उसके बाद मैं तुमको असाइनमेंट देखूंगा तो कम मार्क दूंगा, क्योंकि इंप्रेशन खराब हो जाएगा ना, तो पूरा ग्रेड ही तुम्हारा खराब हो जाएगा, ये पक्का है। इसीलिए एक बार हो गया ठीक है, और बाद नेक्स्ट टाइम यू शुड नॉट बी लाइक दैट। अजय मीना क्या करो, व्हाट इज योर डिफिकल्टी, टेल मी। Which instruction you'll use to get the data from the memory?
Sir, LD.
Huh?
LD, sir.
LD. So LD, then what? Explain LD instruction to me.
Yes, sir.
Suppose LDX plus. What do you mean by that? You are not attentive. The problem is you are thinking it is just like a class or other classes. Let me just sleep. Ajay Meena, please you go from the meeting. You don't be there. Leave this meeting because you are not attentive.
Yes, sir. I'm opening the page.
What opening the page? I told keep it open. Why are you opening now?
No, sir. I'm finding the page number.
LD प्लस में तुमको बार बार बुलाऊं कितना पेज नंबर है, सब कुछ बताया तो भी।
Yes, sir. 112.
तो क्या समझाओ एक्सपेरिमेंट, वो ये पढ़ समझाओ मुझे क्या है, व्हाट इज दैट? LDX प्लस का मतलब क्या है, वो क्या करता है? LD then blank then capital X plus. What does it do? Now LD, then there is a register number, then let's say X plus. 112 LD R30 Z plus. What does it do? 112 में तो उसमें सब लिखा है। You are not attentive. Either you ask questions. Okay, I'll just, because you are not able to, I'll give an example of a code, then you guys do it. Okay, I'll just write a code. I'll take it from a book and just I'll write it. So just give me a second. Give me a second. So I will write this code. I am just taking from somewhere. I'm just giving you this example. For example, write a program to A, clear 20, that is the register. Then B, add 3 to R20 10 times. Then C, send the sum to port B. I'm writing this code, okay? This code I'm writing. Please see. Clear R20 first. So first, you know, I have numbers like 10 here, then 3 here. So these numbers has to be also stored somewhere. So, you know, in the code, when you write assembly code, you have to write some initialization routines. Because there is a port B involved, so there will be initialization routines. And there are many things which will communicate with your desktop, etc. So therefore, there is a file which does this. This is called a already library. So then people do, you know what, include that. Arvind will explain. Tomorrow you please explain this, Arvind, okay? So you write include that particular file, initialization file. This is called initialization. This initialization will put the AVR, that board, into proper thing. That means it will be able to communicate with the desktop. Everything will be initialized. Okay, so let me write this code. So first I have to load this 10 in a register. So I'll wrote this R16 register with 10. Then I'll also have to load, initialize R20 to 0. So I'll load R20 with 0. Then again, I have to load 3 this number. Then I will do it in R21, 3. All right. So then what? I have to do it 10 times. So 10 times means I have to decrement each time R16, check whether it is 0 or not. So I will start a loop here, maybe loop here, loop 1. Then I'll first add R20 with R21. That means this is first it is added. Then what I'll do, I'll decrement DC R16 by 1. When you decrement, you check whether it is equal to 0 or not. So I can write branch if not equal to 0 to loop 1. Then after that, whatever is there, I can set the DDRA already. Then out port B, this R20. This is all. All right.
Sir, for the first code where we are adding the 128-bit numbers.
Yes.
It is enough to just store the result in 4 registers, right?
No, it will not be 4 registers, no, because each register is 8-bit.
Yes,
so
4 is the 32. Oh, sorry,
so
when you're adding 32-bit numbers.
32-bit, yeah, it's fine. You can do that. But try to do 128-bit also, no problem.
So we just have to like write some extra lines in that.
Yeah. Extra line, no. It has to be this branch, this one which this you look at my screen. Look at my screen. I just wrote actually. I don't know. Can you see my screen?
Yes.
So this code I wrote just now. So you can see this is the algorithm flowchart. So all of you please do these 2 codes. Pooja, please create the assignment and upload in this. If you have any difficulty, ask. I am waiting.
Sir.
Yes.
Sir, for the first question.
Please raise your hand while asking question.
Okay, sir. Sir.
Yes, Sainaran, please tell me.
Sir, for the first question, we need to first set up X, Y, and Z to represent the 3 numbers.
Yes, you take any 2, 3, X will be consecutive 16 locations. So you take X, and then if you add 16 locations, 16 to it, you will get Y. Then add 16 or 16 to it, you will get Z. Initial addresses.
Okay, sir. Then we have to use LD to load it into the registers.
Yes. Then you use LD. So.
Okay, sir.
Yes, Amrita, please.
So I wanted to ask that can we take a random address to
Yeah, you can take
initialize
100,
X?
but it should be 16-bit address. You look at the manual, how much is the address value that has, because you will have to have some. You can take any address, no problem.
Okay, and if I have one random address, I'll initialize to X, then add 16 to initialize Y and Z, right?
Exactly. Yeah.
Okay, sir. Thank you, sir.
Yes, Devendra.
Sir, the addition of 2 bits, we need to again shift it
2
to
bytes, 2 bytes, not 2 bits. Byte.
Yes, means the final addition of 2 numbers means A and B, that 128-bit number.
Yes.
We need to again store it to main memory.
Yeah. I told you X, Y, Z. X is the one operand, A, that is so Y is the another operand, Z is the. So these are the 3 locations.
Okay.
Starting X. So there will be few locations which will be keeping this A value like that.
Sir.
Please raise your hand, otherwise I cannot address you. Yes, Amitaksha, please.
Yes, sir. So, how do you make sure that the address stored in register X corresponds to the first 16 bits? First
So
8 bits?
that I told you, I have put it in the memory already for you. Don't worry about it.
So we don't need to write that part of the code.
No, that part. Loading into the memory, you don't have. It is already there in the memory.
Okay.
Asta Bhatwara, are you there? Asta Bhatwara? Asta Bhatwara? Asta is not there. So, Pooja, please make it a point. Asta Bhatwara is not there. Kari Aduvanshi Krishna, are you there? Kari Aduvanshi Krishna.
Yes, sir. Yes, sir.
What are you doing?
I'm writing the code.
Okay. Harshal Lakshman, are you there? Harshal Lakshman. Harshal
Yes, sir.
Lakshman.
Yes, sir.
What are you doing?
Yes, sir.
Which code you are writing? First code or second code?
First, sir.
32 bit or 128 bit?
128.
Pritamanand? Pritamanand?
Yes, sir.
What are you doing?
Sir, I'm trying to understand, sir, actually.
Why? You are not asking questions. I assume that you have understood everything. In 5 minutes time, I am going to ask you some about the codes. You please tell me about LD, LDI, all these things. In 5 minutes, okay? If you cannot explain me, then I assume that you have not attended my class today.
Sir, LDI means, sir, LDI means, sir, just suppose, sir, LDI R1610 means, sir, R16 is equal to, sir, LDI is equal to 10, sir.
So that
Load data.
number 10, what will be the maximum and minimum value? Can I have LDI R16 is equal to FFFF?
X.
You are not attending the class properly, Prithamanan. This is not good.
Sir, I am trying to, sir, understand, sir.
You please go through this and understand, otherwise ask questions.
Yes, sir. Sorry, sir. I'm reading, sir. I am reading this book, sir.
Okay.
Okay.
Sir?
Please raise your hand.
Yes, sir. Yes.
Amrita, please tell me first.
Sir.
Yes.
1 minute, one by one. First, Amrita.
Yes, sir. Sir, I'm a bit confused regarding loading the address into the X register.
Just I will give you an address. Let's see. Let's take the address EF01.
But in the instruction manual, I cannot see any, command for loading into X. It's always taking the register X value to some other register.
Pair. You see, X register is a register pair.
Yes.
So each register has to be loaded with 8-bit value. So can you not do that?
Can you please repeat once whatever
What
you
is X
said?
register?
It's paired up register
Which
in
register? Which pair of register?
Z is 30 and 30
X,
and 31.
X is what?
It's
Find out. Who can answer? What is X?
27, 26 and 27. No, 27, 28.
Sairan bolega na? Sairan bolo. X is?
Yes, sir. 26 and 27.
26 and
27.
27. Suppose your starting address, as I said, E100. Let's say this is the starting address 0x. So you load E1 here, 00 here. Got my point? You don't have to do anything with 26. You have to just increment this. Then Y register, you have to load how much?
Plus 16.
16 means this will become E110 or 10. Similarly, Z register, you will add another 16. Okay. So this will become, Z will be E120. So accordingly, so E1 is not changing. This will be fixed. Okay. The other part only has to change. Okay.
Yeah, but for Z, for initializing Z, I'll have to initialize R30 as E1, right?
Right.
Okay, I get it, sir. Thank you.
Very good. Sainaran, what is your question?
Sir, after doing the addition, how do we write into the SRAM, into the Z location?
Just load is, there is store also. Store Z. CS, store data. See, there will be instruction. You go to the instruction table now, from where you will find all the instructions. The fast program will take time, don't worry. So that's why I'm giving you so much time. Otherwise, in the exam, you'll get 5 minutes to do that. Don't worry, you take time. Go to and find out. Go to the I will say the table of assembly language code table.
Okay, sir.
From there, you find what is the instruction to store back in the memory. Loading from memory, you are done. LD. So store back is what? There must be some instruction. I can also tell you. Just give me a second.
It's ST.
ST, yes. ST is there. ST.
Sir.
Yes. Please raise your hand. Whoever is asking, please raise your hand. Otherwise, I can again Purka. Okay. Please tell.
For 128 bits, for the first 8 bits, we can just use add and then write a loop for adding the
First
next.
Add, then add with carry.
So for the next 15, we just write a loop and use add carry.
Yes, exactly. You got it.
Also, sir, do we need to comment our code for the assignment?
Commenting will be good. If you can comment, it will be good. You just write in the plain paper. Don't have to write in the. Tomorrow there will be demo how we'll run in the code in the simulator. Today only.
Sir, I am writing it on my notepad on my PC.
No problem. With that same notepad, you can just upload. Please upload whatever you have done by 10. Okay. There will be no extra time. So by 10 you do, don't copy. Okay. Again, Amitasya, what is your question? Tell me. Amitasya, you have raised your hand.
No, I actually asked my question. Sir, can you show the second question on screen if possible?
Yes, Pooja, have you created the assignment?
Yes, sir, I have created.
Okay. Go to the assignment, you will check that. You have to find the sum of the following numbers. I have shown in the screen, you can see that. Apurva Anand, are you there? Apurva Anand?
Yes, sir, I'm there.
What are you doing?
Sir, I'm trying to do the second one now.
Last one over?
No, sir, I tried to do that, but then I thought of, you said like the deadline is 10, so I moved on to 10.
That's okay.
Moved on to the
See,
second.
this one is just to, I will not evaluate this upon marks. I will just see how much you are able to do. If somebody has done completely understood, then I will say that yes, this guy has attended my classes properly. So this is just to create an impression, no marking. So do it. If you do one complete, that will be enough.
Okay, sir, I'm trying to do that.
Chandra Prakash.
Yes, sir.
Nausin, please ask.
Sir, I'm doing the first part.
Now, Nausin is asking some question. Okay, Nausin, please.
Yes, sir. Like when we do the addition, like if there is a carry generated, like under like
Add with carry, add with carry. So first lower bytes. First you take the least significant byte, 2 bytes you add. So then next 2 bytes when you add with carry. Got my point?
So like the doubt is like after adding, if I put some other command like some LD and then do ADC, will the carry flag still be there?
You check whether LD is resetting the carry flag or not. That is your job to check.
Okay.
LD will not do that, I think. LD will not affect any flags. Check it from the, I have given the manual. That's why you are there. Yes. Ashish, are you there? Ashish. Ashish. Hello, Ashish. Not there. तुझे उसको निकालो मीटिंग से. मैं निकालता हूँ. तुम उसका नाम नोट करो. Chikala Prem Kumar, are you there? Chikala Prem Kumar. Chikala Prem Kumar भी नहीं है, उसको निकाल.
Sir.
Yes.
Sir,
please. Please ask.
Sir, the second question: can we store the carry? Like, can we get the carry that we are getting and store it in another variable?
The 8-bit numbers you add.
Yes, sir. So I want to add 2 numbers.
Yes. You have to first question if you do, second question is not a big deal.
Yes, sir.
Second question is tricky in the sense if there will be a carry, what will do? If there is no carry, what will do?
If there is a carry, I need to store it, right? Because that needs
so that reflect in the high byte.
Yes, sir.
Sir, how do you store the numbers in the second question?
You'll store in the register, na 20. You are not storing in the memory.
But that can store only 8 numbers, right? 8 bits.
No, these are 3 numbers you can use immediate instruction. Data can be specified there. It is a simple program too. For 1, I will give you a lot of hints. 2 actually is not difficult. You take these 3 numbers, put in 3 registers, keep on adding the lower byte on 20 and higher byte on 21. That's all. But these 3 numbers, make it generalized. If these numbers do not generate carry, then what to do? Whenever it is exceeding 8-bit, then only you will use 21. Otherwise, 21 will be 0. Amrita, what is your question?
So for the first one only, in the loop itself, I'll have to initialize 2 more registers that I'll have the corresponding, register values, right?
Yeah, there will be 2 registers to which you will bring the numbers, then add. Then the destination, whatever is the output, that has to go to the memory. Again, keep on adding. So keep on adding 16 bytes. Yes.
No, I want to know, like in initialization, I'll initialize X and Y with the address.
X, Y, Z with 3 memory locations.
Yes. And later for addition, I'll initialize 2 registers with
addition. You have to use these other registers R0, R1, R2, R3, all the registers.
Yes. So I'll use 2 registers outside the loop and 2 registers inside the loop. Is it the right way?
I don't know what you are saying actually. I don't know. Inside loop, outside.
Like for the first,
all registers will be incremented by 1. Yeah, all registers will be incremented by 1.
I'm
algorithm. See, first you write the algorithm. What is the algorithm? Algorithm is first initialize the register pairs X, Y, Z with the memory location starting. Starting of A, starting of B, and starting of C. C is the result. Then initialize 1 register R0, R1. You bring from A register, let it come to R0, B register, it come to R1. First byte.
Yes.
Then add. Then R0 is the addition. So store it in the Z first location.
Yes.
Then increment X, Y, Z everybody.
Yes.
Right. Then again add. Again bring them. again
Yeah.
add, again replace, again increment, like that. It will go
Sir,
on.
can I use the command that is LD,
Yeah, you have to,
RD,
yeah,
and
you have
X
to
plus?
loop it actually. Just now I have told you, you have to loop, you have to initialize, because there are 16 bytes, so you initialize another register is 16.
Yes.
That every time one you are adding, you decrement it by 1 till it reaches 0, you keep on adding.
Yes. No, I mean for ADC part inside the loop, I'll have to initialize 2 more separate registers, right?
No, everything will be ADC. Initialize, don't use we add without carry. First, you clear the carry flag by using the clear command. Then everything in the loop add with carry. Okay.
No, outside the loop there will be add, and inside the loop it
No,
will be add
why?
with carry.
You keep all ADC inside the loop, it will be good. Why you want to keep another instruction outside the loop? Not required. Initially, you just clear the carry flag.
Okay. But outside the loop it should be add, because we are not, I mean for the first one we are not taking that.
If you take what is wrong? If you clear the carry flag, you can take. It is up to you. Either you do addition 1 addition outside and 15 inside. You can do that. Yes, why not?
Okay.
Okay.
And each time I'll have to keep on storing the addition value that I'll get in some register from ADC R3 R4, and I'll store
तुम एक
R3
काम
value
करो
to
ना,
X
सुनो एक काम करो, तुम एक काम करो, 8 बिट जो है ना, 16 8 बिट वैल्यू ऊपर है, नीचे है।
हाँ,
नीचे क्या होगा? सो एक एक ऐड करोगे, एक एक स्टोर करते जाओगे।
हाँ.
Whenever if there is a carry, you need a 17th location for Z. If there is no
Yes.
carry, you don't need any 17th location.
Okay.
First you
Thank you.
formulate the algorithm, then you go to the code.
Yes, sir. I was confused regarding how to store I mean, when at what point of time I'll have to store the values back into the memory and
Every time you add, you store. Then increment is X, Y, Z.
Okay. Okay. Get it.
Now,
so how I'll use Z register here while
Z
storing?
register will be a result. You have to store in Z register. Na? Load from X, load from Y. A will come from X. Y will come from, A will come from X. B will come from Y. And C will go to Z.
So we are using X, Y, Z just for the address locations, right?
Right.
Okay. Thank you, sir.
Nanjyoti?
Yes, sir, I was asking that, like, when we write LD R0 Z plus, then
Yes.
Z is a location which have 2 bytes.
Z is X. X is the source. Okay, X plus, let's say.
Okay, sir, X plus. Then X plus has 16 bits. But R0
X,
is...
no. It is the data memory, it is 8 bits.
Okay, sir. Okay, sir. Okay, sir. Sorry, sir. Thank you.
Okay, Ansari Mohammed.
Yes, sir. Is there a way to decrement the pointer, like?
Yeah, Z minus post decrement is there.
Sir, but that doesn't that affect the value instead of the?
No, it will just decrement the count address. That's all. Increment or decrement. Oh, which one you want to decrement? That 16 number.
Yes, sir. Like I am adding the.
A lot of DC or DEC is there. Many commands are there. You look at the table.
Yes, sir. That only I'm trying to find, sir.
You have to go to the instruction table. Last time I gave the table to you.
Yes, sir.
You go there and you'll find decrement is there. And from the detailed manual which I've shared today, you can find out what is that.
Yeah.
पेज नंबर कितना होगा मैं बता देता हूँ. पेज नंबर 84 में डेक है DEC. It will affect all the flags Z etc. 84. आलोक अग्रवाल, हेलो आलोक अग्रवाल,
Yes, sir.
क्या कर
Yes,
रहे हो?
sir. Sir, like
3
I'm
मिनट है, 3 मिनट
like
का अंदर जो करना है करो, और मैं कुछ नहीं पूछूंगा, 3 मिनट, ठीक है?
yes, sir. Yes.